This is a video showing the creation of a sinusoidal waveform or sine wave by plotting the height of the circumference relative to the center point against time. The circumference of a circle is 2 pi radians in length, and so a basic sine wave is also going to be 2 pi radians in length. 2 pi radians is equal to 360 degrees, and so a circle can be broken down into both. Here is the full equation of a sine wave. A being amplitude, B being relative to the period, C is the horizontal phase or offset, and D is the vertical offset. Here I've made a Matlab code to discuss each part of the sine wave and their effects. Firstly, it's important to note that while the sine wave is continuous, our Matlab representation is a discrete signal, and it's important to pick the right sample rate or samples per second to represent it. As you can see, the 10 samples I have picked here aren't good enough to represent it, and so further on I'll pick 360 samples per second, as this number both helped with coding and also was good enough. Here is a basic sine wave. It's 1 period per second and has a frequency of 1 Hz. By changing the values in the previous equation shown, such as the B value, we are able to increase the frequency from 1 Hz to 2 Hz, which doubles the amount of cycles per second that we see. By changing the C value, we cause an offset. An offset can be thought of starting to count the sine wave at a different point in time. Here is a good representation of an offset. Instead of starting at 0 like we did at the beginning of the video, we travel along the circumference until we have 60 degrees, and we can start measuring the height of the circumference from here. This offset means that two sine waves can start at different points in their waveforms. By changing the A value, we can change the amplitude of the waveform, which doubles its peak values. So instead of having 1 like we did before here, we now have a peak value of 2. And it goes down to have the same peak value at the bottom of 2. Here is a circle broken up into x and y portions. We can use this to show complex numbers where the x-axis represents real numbers and the y-axis represents imaginary numbers. By converting the circle into complex numbers, we are able to add sine waves together through adding complex numbers, as long as the waveforms are at the same hertz.